Okay, so we're live. So, hello everybody. Welcome to TST meeting here. It's our first one this month. We said to skip one because of lack of topics. As usual, we'll open up with some acknowledgements for community contributions. David, do you want to speak to that a little bit?
Yeah, I just wanted to give a shout out to Satish and Kayan for running a recent meetup in Bangalore where they spent an afternoon talking to people about ONOS and helping them get set up with their development environment and getting to start an app. And I think this is going to be a great model for us going forward about how we can run similar sorts of meetups and events through a possible ambassadors program. So there's a link there that talks about how do we build on what they've done to build an ambassadors program. So if people have thoughts, comments, suggestions, we'd love the feedback.
Oh, perfect.
Yeah, it looked like it was a great event.
Yeah, that's awesome. Well, thank you guys. There are two things on our agenda today. One of them is, well, they're both related to driver-related work. One of them we've discussed in the past, and that's driver-based providers. Except that this time we're going to report, rather than a proposal, we're going to actually report on what was done. And Andrea is going to lead that discussion. I think we can probably do that right now. Yep.
Okay, so the first slide. So we wanted to provide some fallback providers in order to be able to configure devices and have device-specific behavior in the driver subsystem, providing a clean abstraction and enabling the device or the protocol to have an implementation, configure the devices, especially for the fixed functions, but without bypassing the core and letting the core know everything that is going on. And also, the goal was to provide selective support for control features that were not available on some devices or on some protocols. And also reducing the boilerplate code, because implementing this device-specific protocol would be very costly and very time-consuming and error-prone. And also, we wanted to have the same ease of use for the northbound, so the applications and especially applications and command line have a transparent device interaction without knowledge of the lower level of what is happening at lower level. So just a little bit of background. Right now in ONOS, the device provider discovers the device via device ID that's backed by a URI and it has a schema. The schema of the device ID identifies the provider family and is the mean to dispatch an event or a call to a specific provider of that family. But if the family does not have a provider for a specific call, it doesn't there's nothing happening. So what we did was providing a fallback flow rule group and packet provider. Those are the fixed functions that we wanted to tackle first, because those are the most important ones regarding our ONOS core. And so we provide a driver provider, that's flow rule driver provider, group driver provider, it's whatever name, driver provider.java. And this is created and registered by the manager of each subsystem. And this gets used only if the specific family of devices doesn't have a standard device provider. So if, for example, the OpenFlow device providers will have the OpenFlow flow rule provider. That's there, and it gets used for the OpenFlow providers devices. But if we have another family, let's say netconf, we can use the default driver provider. And that driver provider will use a specific behavior interface that's called something programmable And that specific behavior interface has to be implemented by the class that will have the protocols and device-specific implementation for that specific fixed function. So if you want, let's say, a netconf device to be able to accept flow rules, you have to implement the flow rule programmable, and that would get called by the flow rule subsystem. And in the programmable implementation, you will have the device-specific calls that you have to make in your own protocol, netconf, SNMP, REST, whatever, in order to apply and poll the flow rules for that specific device. So this way, the ONOS core doesn't care about how we talk to the device. The application doesn't care about how we talk to the device, but what we care about is the final result, the ending result, and that's it. So as a general overview, as I said, the default providers are there, and they are used for the already existing protocols that provide a provider in their own family. But the driver provider classes are there for the families that don't provide it, and they use the driver service to get the programmable behavior for that specific device that's specified in the driver, and they use that to talk to the device. As an example, we can see an apply flow rule request. If it happens with a device ID of OpenFlow, it goes through the OpenFlow rule provider subsystem and goes down to the OpenFlow device. If it comes, let's say, for a netconf device, we get the flow rule driver provider, and he asks the driver service, does this device have a specific flow rule programmable implementation? The driver service checks the drivers. It finds the flow rule, the full flow rule behavior. That's an implementation of the flow rule programmable. It returns it to the flow rule provider, and that's it. And that is used to talk through the netconf protocol to the device, and that's how we do the fallback.
Just one quick note here, this adds an extra level of flexibility, because even when using the same protocol, like let's say netconf, devices may support different models for doing that, and you can't use just the protocol-specific provider to encapsulate that. You have to actually go device-specific.
Yes, because there is no general thing like OpenFlow. So every device that talks OpenFlow understands a fixed set of calls. Every device that talks netconf maybe understands a fixed set of calls, but maybe for the flow rule, it has to make like a different set of ones that is different from a Fujitsu or whatever other device that you could use in the netconf. We modified the abstract provider registry in order to support this fallback providers. And right now we implemented it in the flow rule, the group, and the packet. Let's say somebody else wants to implement it in another subsystem. It can be done. It's fairly easy. For example, in the tunnel, for the tunnel manager, you create and register a tunnel driver provider and register it in the tunnel manager, and define it tunnel programmable.java, and override in the tunnel manager the default provider method, providing the instance of the tunnel driver provider. So it falls back to that one in case there is no default tunnel manager. So right now we can support the interaction with legacy devices, legacy protocols, and custom models through a clean abstraction using the drivers. And also we can mix and match different protocols and different actions for a single device, because not all the actions need to be done via the same protocol. It can be, we can use different protocols because we provide an abstraction. So it's the implementation of the behavior takes in account all the protocols and all the different things that has to be done for the device to implement a specific function, but we don't care. We provide the abstraction of the behavior in order that everything else doesn't see this code. And it provides backwards compatibility. There's no change to the already existing things, and as I said, the ONOS core remains insulated, and that's what we wanted to gain, because we don't get tangled with protocol-specific code in the core. As a future development, we might want to do this also for the device providers. This is a bigger step, but as we were developing a netconf REST and SNMP providers and protocols, we saw that some code, especially for the device providers, is duplicated, and it's boilerplate code. So we wanted to maybe provide an abstract base as a device, basic device provider that each, let's say, protocol can augment its own, and normalizing the device provider behaviors with the device-specific code and protocols. That's it.
All right. Thanks. Thank you, Andrea. Is there any questions? Or?
Yeah, I have that. Can you go back to the first page? From the beginning.
Which one?
Yeah. It's a, how do you define what's the meaning of bypassing the ONOS core?
Can you, Tom? Can you go to the general overview slide? The one. Okay. So, what I mean by bypassing the ONOS core is that we want something to happen. We have an app, and that app, instead of calling the normal, let's say, flow room system, it goes directly to the driver service, gets the behavior for the device, and talks to the device. In this way, the ONOS core doesn't know anything about the flow rule that gets installed via this driver. Instead, using the default driver provider, we can call the ONOS core and the apply flow rule that is already there, and that uses the driver for this, the behavior for the specific device, but has knowledge of what is happening.
So you want to know the content of the flow rules, or you want to know the? I don't think you want to know the flow rule, right?
No.
Yeah. So what's the Andrea side?
We have so we're just to be clear, we're not bypassing the ONOS core. You got that, right?
Yeah. I know.
We're not bypassing.
Yeah.
I just want to make sure we're clear on that. So today, applications, when they want to do flow rule operations, they go to flow rule service or flow objective service, right? They go to one place. They can execute those operations in a sort of a location transparent manner, where no matter which node they are on, they can, even if they're on node A and node Z has a connection to the device, it doesn't matter. They don't need to care about that. The operations are going to happen. If they were to directly, if there was some family of devices or some protocol that didn't have a provider, or a provider could not be effectively built because of nuances of the devices, that would force applications to, in order to control those devices, to invent their own means of control, either using device drivers or completely bypassing the core, even not using device drivers. Clearly that's bad, because first of all, now you have two different ways of doing things. You're bypassing the core and some of the benefits that the core provides, location transparency, enforcement of the flow rule table, and things like that. So we wanted to make sure we allow easy delivery, easy integration of that functionality for esoteric devices, or not even esoteric devices, maybe it's too strong of a word, for devices where standard protocols may not necessarily very well apply. Even like in the case of netconf. Yeah, we know how to speak netconf, but it doesn't really matter if you don't speak the right model of the device. And so that is device specific, that's not protocol specific. So we basically need to have a way of choosing what to do, not just on protocol basis, but on device basis. And these fallback providers effectively give us that. If there is not a protocol-specific provider to accomplish something, then we basically fall back and go to a device-specific provider. That's what the fallbacks do.
Okay. Okay.
But it's still the purpose of the provider to map from a common abstraction, the flow abstraction, if you will, to the device specifics. It's just a different way to map it.
Absolutely, yes.
Yes.
Yes, and it's completely congruent with the provider mechanism, right? It's basically just narrowing things down. The providers were originally intended to be protocol specific, but we've soon realized that that's not enough. We also need to devise device specific mechanisms.
Yep.
I mean, even our open flow provider uses the driver mechanism to be able to negotiate the handshake and other interactions through drivers, because there's device differences. So this way, we just basically formalize this relationship, and we have the reason it's a fallback. It's basically saying if nothing else works, work with this. But that doesn't necessarily mean that it's less important just because it's a fallback.
And if you take a look at the behavior classes, for example, flow rule programmable, it mimics exactly the flow rule provider interface. With apply flow rule, remove flow rule, and that's it.
Yeah. I mean, there are subtle differences, but it's an analogous interface.
Yes.
Okay. So another question is about this. So we're talking about the layer 3 topologies using the driver mechanism to collect the state. Okay. So now, I want to figure out the relationship between these driver providers and the drivers.
That will come next. So
you have the next.
The topology is more about model extension. This is more about providing the existing fixed function subsystems with ability to engage in device-specific behaviors.
Okay, so my understanding from based on your you guys the presentation is so the network state still goes through this driver mechanisms. So the driver providers, if they need the information stored in the device drivers, they can use their APIs to talk to the driver, right, to collect those topology information. I was trying to figure out once we implement the driver layer 2, layer 3 topology through the driver mechanism, once these guys plug in, is there any effect on the driver layer 3 topology implementation?
I'm not sure if I get the question, but if what you're saying is, does this is your layer 3 driver regarding fixed functions in ONOS, like the flow rule, the group, and the packet? No, so it won't.
It's just the topology.
So it won't.
Yeah. So this is nothing to do really with the L3 topology.
A couple questions. It's possible that these drivers have specific information, other credentials for logging in. Where is that data meant to be stored? How do you envision that happening? And how do you envision these drivers to be loaded? Do you see each driver potentially as a separate app that gets added, or is there like a directory that you dump jar files in and they're read type of thing?
So so a couple of things. There's a couple of questions there. First of all, the credentials that's being addressed right now, as a matter of fact, Brian Thanke is working on a device key subsystem to be able to allow ONOS to essentially carry around a set of keys that it can use to interact with devices, and whether they are community names, user passwords, or SSL certificates or whatnot, it doesn't really matter. The keys can take multiple different form factors, and one should be able to use those to engage with the devices. The providers or the drivers can use those to engage with the devices. So that'll take care of the security bit.
There could be other data as well, but okay, drivers may have their own systems that they care about, and stuff to associate with nodes.
Well, so then there's just and then there's the code. How do you load the code? The code is, first of all, delivered as anything else that's optional in ONOS, which is ONOS apps /extensions. You install them, activate them, great. Now, the thing is, the drivers themselves are not necessarily just the code, which is the implementation of the various different behaviors, but it's also the configuration, which is which behavior implements what sort of, how is each behavior implemented, and what device families support which types of behaviors. That's delivered via Terray. I mean, the easiest way to deliver these bindings is via XML file. You can, of course, do so programmatically equally well, but XML file is usually the best way to do it. And this is, you know, as you recall, one of the other driver-related works that happened in the past 2 sprints is restructuring the driver module so that we have vendor-specific families, because those will most often share, well, first of all, share code, and also generally going to be delivered together. So the drivers get delivered as applications and with Java classes and with XML files that prescribe how they get stitched together. They then get the instances of these behaviors then get created automatically by the driver service subsystem.
Right, thanks.
Did that answer your question?
Yes.
Okay. So if there's no other questions on this topic, we can probably switch to the other driver stuff. Will be probably
I'm going to try to say something.
Hello. Hello. Can you hear me? Hello.
Yes.
Yeah. Hi, Thomas. This is Satish here. I have posted one query of my understanding in the chat. Can you just check whether if my understanding is correct?
At least you can post on the chat. I can't post in the chat. It just doesn't work. Oh, well, that's interesting. Now it appeared.
Hence, device, can I use SNMP to push rules? Yes, that's the whole idea.
It says in the chat, but I can't type anything in it.
Got it. Got it, Thomas. Yeah. Thank you.
Yes, that's what we meant by mix and match.
Got it. Got it. Yeah.
Yep. Okay.
Yeah. Thank you.
Sorry. Okay. So now to the second part, which is I called it.
I guess I'll ask you my question later then.
Oh, sorry, Bob. What was that?
Sorry, it's been hard to get a word in edgewise, and none of the online systems for asking questions work. I was just trying to clarify, like, what's a practical, in a few words, what's a practical example of the problem you're trying to solve here? Because this all seems kind of abstract and sort of, in my opinion, or from my perspective, really pointless. Because I can't imagine ever trying to program flow rules using netconf. It just seems idiotic. So, what exactly is the point of this?
Well, merits aside, I mean, that's how, the protocol is rather irrelevant, right? It's what's really important is what it allows you to do. And so, sure, I'm all for standard protocols because that minimizes the number of languages that we have to speak to the devices, or specifically standard models too. But if they don't exist, if the device allows you to do something, but you have to speak, gibberish to it, why not speak gibberish to it? That's fine.
Yeah, I guess I'm just really unclear of what is the practical problem that you're trying to solve here.
So, well, sure.
Are you?
Yeah. Very quickly, we have SNMP devices, netconf devices, or potentially devices that use REST to get controlled, and we have a need to be able to control them, discover them, and program them and control them. And if those are the only means that they allow us to do today, well, we already have a mechanism to deal with device specifics for other reasons, even just in a context of the regular standard, let's say, open flow.
Yeah,
so
the thing that I'm really having trouble with is the abstraction the only abstraction you mentioned is flow rule provider, and it just seems crazy to implement flow rules using SNMP or something. I can't imagine that being a practical or sensible idea. So what exactly is the abstraction the real abstraction that you're using? Because it can't be flow rules, right? That doesn't make any sense.
The point is, some people do, for better or for worse, use SNMP
Well, yes, some people do. The question is, do we, and do we think it's a good idea? And is it a sane idea for ONOS? And like, why waste your time on it unless there's a really compelling reason? Like, what's the compelling reason, I guess, is sort of the question that I have.
I mean, it's a valid question, but I think we're presenting with enough cases where it's for us to engage with devices on their own terms, and this simply gives us a way to do that. I mean, OpenFlow 5.0 comes out with some concept, and we're gonna be, and we certainly don't want ONOS architecture to be stuck in the mud just because it's not equipped to deal with it. With the new abstractions, you know, with the existing sort of level of isolation that we have from the environment, we benefit from it on either end. We get to exploit the standards, standard protocols, standard models, but we don't depend on them. We don't depend on their existence or on their stability. So they can move backwards or they can move forward, and we really don't care, and we just adapt to them. Yeah, it's just it's not really that much code. It's just setting up just few, just sort of breakaway points in our architecture that allow us to nicely and crisply separate the device specifics and protocol specifics from everything else. And this is simply just an enhancement on the same.
Yeah, I guess my point is perhaps that, you know, whenever you add an additional layer of abstraction, you should probably have a really extremely compelling reason and sort of practical problem that it's solving, and I just don't see that here.
It's not an additional one. It's basically it's.
Oh, I guess it's a layer of indirection rather than abstraction, but.
Sure. Yeah. It's an indirect.
So the thing is, whenever you add an additional layer of indirection, it solves one problem, perhaps, but it creates another one, and that other one is now you're one further step removed from where you want to be. And debugging becomes that much harder, and maintenance becomes that much harder, and all those other sorts of things. And you've contributed towards the tragedy of the commons of too many layers of indirection. And so it seems to me that a sensible way of approaching this is that you should really have, you know, there should be sort of a high bar to meet as far as explaining, you know, clearly why this is justified. And I was very frustrated by this presentation because the justification that was presented was really not very compelling and didn't seem to make a lot of sense.
Well, so it was assumed that it's given that we have devices that we need to control which don't comply necessarily with the standards. So to answer your original question, is it worth it? Yes, it's worth it. We have to do it. This is a fairly simple way of doing it in an evolutionary way.
You see, it's very frustrating. I guess I don't know how to formulate the question, but my basic question is like, why did you do this? Like, why does anyone think it's a good idea?
Bob, we did this because eCode supports 3 devices: one talks SNMP, one talks netconf, and one talks REST. We want to do something with those devices. We need this system. If we don't want,
what is the something? Okay, now that's more interesting. What is that something?
We need, it's the eCode project. We need to be able to tune at least the wavelength of devices, and that is kinda the concept of flow rule tuning, because tuning the wavelength is tuning where the traffic goes. So we need to do that, and this is the means to do it, having the ONOS core knowing what is done and what is there.
Well, that's really interesting. It sounds to me like that you may be working with the wrong abstraction there.
The problem is that we have the protocol.
Yeah, okay, but at least thanks for giving me a straight answer, because if you'd given that, you know, to begin with, it would have given a lot more context and made it more sensible. But your straight answer, as far as I can tell, is that, you know, you're trying to shoehorn these devices which don't fit well into one of ONOS's abstractions, and so you're sort of changing the implementation of the abstraction behind the scenes, which maybe isn't the best idea.
Whether or not the abstraction is a correct one or not, it's somewhat side subject here. It's close enough, and for the time constraints and the function and the sort of scope constraints that we have presented before us, this was deemed to be the shortest sort of approach to use the flow rule abstraction. So that's that. The decision was done on that, and then now we needed to be able to act on it and implement it in a reasonable way. And this was the shortest path, which provides also the furthest, what?
Yeah. Okay, thanks a lot for the explanation. Yeah, without that explanation, none of this made sense at all.
Okay. All right. So let's next talk to the slightly different subject, which is how to model various, how to work with the ONOS model and how to extend the base entities. So we were faced in the past and are faced again with the need to be able to extend the ONOS core model. Things like devices, links, and hosts, and things of the sort, which were purposefully kept rather simple, almost naive within the ONOS core. But the application now needs to be able to decorate them with some of their own data. For example, the optical application, I think in EMU, needed to be able to introduce new types of ports. And so we simply just subclassed port and call it, OCH port, and decorated with various optical attributes. It still provided a nice abstraction, but now the port became specific to the medium, which is great, fine. Okay, we used basically extension. However, it had a number of disadvantages, a number of issues with it. Specifically, a lot of our stores had to now become aware of all of the leaf class extensions, the base model entities, and so forth. And so we wanted to step back and take a look at what is a better way to accomplish this. So the idea is definitely to allow extending the core model entities in a dynamic fashion. So it means an application should be able to be installed at runtime and can extend that model.
So can you clarify what you mean? What you mean by that? Data or extending the behavior?
What?
Do you mean extending the? Oh. Do you mean extending the data or extending the behavior?
Okay, you go, Bob.
Sorry. When you speak of extension, yeah, I'm getting a lot of echo on your side. When you speak of extension, what do you mean by that? Do you mean adding new data components? I mean, do you mean instance variables, or do you mean methods, or what exactly do you mean?
Yep, those.
So that's kind of interesting. So you're proposing, yeah, okay, very interesting.
Okay, so you have a device.
If you permit adding methods, it doesn't solve your base problem.
Time out. Let me please finish through this, okay? And then we can discuss it, or at least let me finish a sentence here.
Sorry, there's a bit of lag, so that's why we're colliding.
Okay, so let's minimize the handoff here. So we're trying to allow applications extend devices, links, and hosts. Extend is in terms of like what you would normally extend through a subclass. Okay, adding methods, projecting additional entities, and so forth, and relationships. Now we're only concerned with the existing core model entities. For new stuff, applications are, of course, already able to model their own entities and model their own associations with those entities or the core entities already, directly. They can do that, no problem. So we're primarily concerned with just extending the core model entities. We also want to maintain the base model entities as simple as they are. We want to prevent ONOS core from class explosion, which is thing that happened to SIM model. It's a bloody mess. We don't want that to happen to ONOS. And we also want to avoid ONOS stores having to know subclasses a priori, which, if you really read that, doing otherwise would contradict the first bullet, which means we wouldn't be able to extend things dynamically. Okay, so those are the goals. Now, if you use the extension mechanism as we have used with the optical application thus far, where we extend things via class inheritance at build time, that does not give us dynamic extensibility, and it pollutes the store, so it violates some of the goals. So the idea here is instead to use projection principle, where you basically, the thing is for what it is, but you decide to view it as something else. And you can view it as something else at runtime. And we already have a mechanism, as the driver mechanism, to be able to basically load and map implementations and behaviors at runtime dynamically, basically where a device can change personality depending on what code is loaded. So this mechanism is already there, and essentially acts kind of as elastic inheritance or implementation mechanism, something that Java doesn't provide, where you can mix in stuff. So this is essentially, so we're using the mix-in capability the driver subsystem gives us at runtime to implement this. So how we've gone about that is we took the existing abstract model, we left it, but we built on it as an abstract projectable model, and we added ability to be able to test whether something is can be projected as a certain class. And then we provided ability to project it as a different class. So this way you can view something as something else. Now, then we took the device, host, and link and have those extend the abstract projectable model, which gave us these abilities for those entities. And then because those entities were already annotated with an immutable key value map, we use basically the backing annotations as an implementation of the driver data, which is required for the driver mechanism. And so this is just some, just some sample usages to help you visualize how this is. So let's say we have a device. It's just a plain ONOS device. We can say device as microwave device. And that's going to give us a projection of that device as a microwave device, and then we can operate it on it as if it was microwave device. But in the back of in the stores and everywhere else, it's just a device. And you can, so this is how you can use it for modeling exercises. So if you want to be L3 IP device, well, you just project it as that. Now, of course, that means you have to have some information stored a priori with the device to be able to project it as that. And it also means that you have to have the proper driver configuration set up so that you can project the device as that.
So is this essentially just have it backed by a map then, and you're just doing name value lookups and puts through a class?
Yes.
Okay.
Okay. But you can also project devices not only for modeling purposes but also for control purposes. Like for example, in the second usage on the bottom, you can say, is this device does this device support controller config? And if so, great, project it as a controller config and then operate on it. So it can what?
Yeah, it should be. Yeah. No. I mean, you're right. I mean, it just went with is. Yeah. And the driver subsystem eventually says has to be. We just went for short.
Yeah. We can provide them log.
You can provide them log because it's
yeah, I don't think you're being asked. So that is basically the gist. Is now, as of a couple of weeks ago, you can project devices as something else. You can inject information. Now, the injection of the information, because these things are still immutable. We did not violate the immutability principle, which means that if you want to view something, the device, let's say, as something else, or even a link or a host as something else, you have to have supplied the information up front during at providing time when you've detected the device or the host or link. or when you update it, you have to update it with that. So these are, at this point in time, these are really supporting only view-only projections. They're not mutable. There is, I think, a compelling use case to support mutable operations, but and there's an approach that I at least have in mind, but I don't think that's I think that's something that will require some thinking through and discussion. And so I prefer to start with a simple view-only projections at this point in time.
Is there also a migration issue here that when I add a new presentation class or projection class to kind of go evaluate all the objects in the store and say, okay, if this can be projected as this new thing, I then need to write some default values to it?
I mean, if you had a behavior like that, that would be a problem, but I would hope that that would not be the behavior that we would choose to do. If something is projectable, it'll have everything that it needs, or it won't, or it'll have some reasonable defaults for the things that are missing.
But either you know that something is projectable as something, or not, or it's not.
But let's say I didn't have a projection. Day one, I install a microwave device projection class, and I go about that. And day 10, I install I don't know, a super microwave device projection class, and there's difference in data. There's additional data that this new projection has. It can either be defaulted in the new class, which says, hey, look up this data. If it doesn't exist, throw in a default. Or I could be evaluating all the devices and saying, let's migrate my data because I've added a new projection class, and any device that qualifies for that projection class needs this new default data.
So let me understand what you're saying. You're saying you have a device that doesn't have a projection or has a projection, but you want to update that projection to the new
or
version
add an entirely new projection.
Okay. But then you can just, I mean, correct me if I'm wrong, but you can just update the device and say there's a new projection. Now, what you've provisioned using that projection might have to change, but that's really up to you because you've built the projection, so you better know how to update it.
Yeah.
One quick question. So you see I was trying to understand about this. So you have a physical device there. Mm-hmm. You want to give a different view to take a look at this device. Mm-hmm. You build the one projections, right? And if that one this device exists in the different projections, to create the each drivers to take a look at this one, right? Each projections per driver is one.
So, I'm trying to understand your question.
It's something like I have a physical device there,
yes.
Right? Uh-huh. So I have layer 3 topology protocols to collect to build the layer 3 topology,
yes.
Right?
Yes. So you have something that's able to. Yeah.
Then I can project my device into the layer 3.
So I think, and maybe I'll try to answer both questions at the same time. David, your question as well. So let's say you've discovered devices as plain device.
Okay.
So there's no any additional information injected in it because the base sort of provider just knows it. Yeah, that's a device. It's very nice, and just detects it, and in core it's just a device. At that point in time, really, even if you then install the set of drivers that would normally allow that family, that type of device to be projected, right? Then you don't have the backing data to be able to project it, and I think that's David's question. Okay. So we have a couple of choices there. We either have reasonable defaults for that, or we decline the projection. To answer your question, Patrick, normally, let's say if you discover the device first as a plain device, and then suddenly install an application, let's say like the ID topology application, which could decide, and I think this is what Ali was alluding to, it could decide to take a look at the environment again, and maybe this time it discovers the device as an IP device.
Okay.
then in that case, it will supply the necessary information to support that projection.
Okay.
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 But then you can also have a situation where you discover where the device itself is viewed as two separate things. You may have a L2 device and L3 device, view those as separate, and have a relationship that ties them together. Okay. That might also be a possibility. Okay. And so what I wanted to avoid with this is just proliferation of different flavors of devices and different flavors of ports. And allow applications that decide to take a sort of just an inventory of just a day's inventory, they should still be able to operate on these entities without being familiar with specific projections. They can look at it, yeah, it's a device, and then be able to deal with it as that. But of course, you're limited on how you can deal with it, unless you know what kind of a thing it is and be able to interact with that kind of a thing, whether it's an optical device, microwave device, or whatever else.
Okay, so the device ID in the base and projections is the same or the different?
Well, that's what I was told. So we have two options. You could view device as L2 device with one ID, and you could put an additional projection on it as an L3 device with the same ID. Yes. That's one way. I don't know that, but that approach may have some benefits and some limitations. Or you may potentially just say, you know what, this is L2 device, and even though the same iron is backing this, I'm going to represent the L3 as something different.
Okay.
And may have its own identification. And whether or not you manage the mapping between the two somehow, it's a separate subject. Okay. But so there's choices. In case of optical devices, let's say what the microwave devices, the idea here is just to support those as devices of their own.
Yeah, yeah. I think the benefit for the different devices is that, from the application point of view, if I want to access the projections, I don't need to specify I go which direction, which projections. I just use the different ID to identify which projections or the base to
no, you still have to. You still have to project it.
I still.
So in a device, you still go to device service. You still use the same. You still use an ID to find a device, or you still iterate over all the devices. You can filter them based on type or whatever criteria, and you decide one by one whether you want to project them as something else or not.
Okay.
And whether you have the ability to do projection or not is really depending on the driver that's associated with the device.
Okay.
And so generally, I would think that only optical devices would support optical projections, only microwave devices would support microwave projections, and so forth.
Okay. I still need to figure out how to access these ones through the applications, so that we can. Yeah. If I have more questions, I can talk to you offline.
Yeah, so this is just a mechanism to support extending the core entities.
Yeah.
Core entities only.
Still think there's market layers.
All right. So I think that was all we wanted to talk about today. If there's any other questions, please feel free to ask. Otherwise, I think we need to move on.
And to the battery question, I feel it is like from the application point of view, I see this as a normal device, how the core existing currently maintains it, but the core now gives extra provision of projecting it in different way, so that the applications can see it in different model altogether. But still, the contents, everything is still maintained in the core, and it just looks as a flat device and the links. Am I correct? Yeah. Okay.
Yep. That makes sense.
Yes.
Okay. There's no questions. Thanks everybody, and have a nice day. We'll see you next week.
Great. Thanks.
Yeah, thank you. Bye.